both of them. Okay, so we're gonna go over Unit 1. I'll spend a little more time on this because this was the earliest thing we did, and most likely to forget, for you to have forgotten. Okay. So this, I put it up. You can print this. You can't write on it because trying to get this right. So this first part says, fill in the table, the mapping diagram, and the graph with a relation that does not represent a function. So if you recall from function, what does not, that does not represent a function? So if something repeats in this table, then it's not a function. Is it X or Y?
Y.
It's X. Yeah. So if X repeats, then it's not a function. So I can say 1, 2, 2, 3. So that would not represent a function. I can plot this same thing for B since I already got a table. So I have 1 and 1, 2 and 2. Okay, yeah, 2 and 3, and then 3 and 4. So these two right here, like if you did the vertical line test, remember the vertical line test? If I drew a vertical line through my graph, if it hits more than 1 point, then it's not a function. So if I draw a vertical line here, it's going to hit more than 1 point, so it is not a function. Yeah, remember that? Vertical line test. X repeats. Okay, and then the same thing, I can take the same function. My input 1, 2, 3. My output is 1, 2, 3, 4. So I go 1 to 1, 2 to 2, 2 to 3, and 3 to 4. Remember, if it branches out like a gator mouth, like a V from this side, then it's not a function. Any questions? Let's go ahead and take our mass break and then come on back. Okay, so why do these not represent functions? X repeats. And you can print this out and go along with it at home. That's for A. B, no, that's too much. B fails the, let me put it here, X repeats. This one fails the vertical line test. And I'm gonna write one statement here. Okay, so there is more than one output for each input. That's the formal statement, because that's the definition of a function. For each input, you have only one output. So notice here, for 2, I got 2 outputs. I got an output of 2, and I got an output of 3. So that means that this input has more than one output. So that makes it not a function. Okay, so now this is something that does represent a function. And watch what I do. And it's in line with what you answered first. This actually is a function, even though Y repeats. So let me plot it and show you. So 1 is 1, 2, 3, 4. That's not 1. Ignore that. 1 is 4. 2 is 4. 3, its output is 4, and 4's output is 4. So if I did the vertical line test, each time I would only hit 1 point. And on a mapping diagram, it looks like this. So we don't have the alligator mouth coming this way. So it is a function. That's a 4. So that's a function. It's just a horizontal line, but it's still a function. So it's a function because each input has exactly 1 output. So that's the definition. That's the definition of a function. Each input has exactly 1 output. So this one is a function. Okay, let's look at I'm trying to remember. Function rule, okay. I'm trying to remember this one, y'all. I know how to do it in terms of unit 2. But we can do this. Okay, so where x is 0, y is 1. So I'm going to do the y equals mx plus b thing. So where x is 0, y is 1. That is my y-intercept. So it looks like here, I'm just adding what each time? I'm adding 1. And here, I'm adding 1. So my slope is 1. So that would be my rule, but we don't write 1x in the 8th grade. We say x plus 1. So this is my function rule, y equals x plus 1. So we got the y-intercept, that's where x is equal to 0. And then we got our slope, which is changing y over changing x. I forgot that right quick. Okay, here, my y-intercept is 5. So let's see what my slope is. Go from here to here. So I'm going down 2. That's my rise, and over 3. Down 2, over to the right 3. So that's my slope. So that would be my function rule. Okay. Any confusion on that? Y'all should remember this from linear functions also. So you might want to write it down, or I'm recording it. So go back over it with the video because I want everybody to, my 6th grade test I just gave, my lowest score was 100. I mean, it was 80, and that made me happy. Everybody else was 100. Okay, so create a function rule to find the number of tiles in figure N. How many squares would be in figure 10? This was the one that gave y'all some fits. So we're going to let our figure number be our x. So when x is 1, y is 3. Let's do it like this. Let me start over. So let's do a table. Here, when x is 1, y is 3. Here, when x is 2, y is what? How many I got there? 5. When x is 3, y is 1, 2, 3, 4, 5, 6, 7. It's like I'm adding 2, looks like. And when x is 4, y is 9. Okay. So my change here is plus 2. And my change here is plus 1. So my slope is plus 2 over plus 1, which is 2. I got to find the y-intercept. So I need to know the value of y when x equals 0. I'm going to change colors. So what do I need to do to find when x equals 0 to go to 0? What am I doing from here to here? Am I adding 1? What am I doing? Subtracting 1. So here I'm going to subtract 2. So that's my y-intercept. Because I got to get it to x equals 0. I subtract 1, subtract, I just went backwards. So my y-intercept is 1. So my function rule is y equals 2x plus 1. So they said, then the next one said, how many squares would be in figure 10? So that would mean x would be equal to 10. I should have made that an n. So that's equal to 21. 2 times 10 is 20 plus 1. So all I want you to do is substitute 10 in for your input. Okay? So that's that one. And again, I'm recording this so you can go back over it if you need to. And I'm looking at these fresh. I will confess, I just posted these and I didn't look at them. But I taught it before, so I should remember it, right? Okay. So this one is graphing linear functions and making predictions. So what is my slope in y equals minus 3x plus 2? Are we lost? Let me remind you of something. Y equals mx plus b, so it's some number in front of x plus a number out here by itself. And m is your slope, and b, for some reason, is your y-intercept. I don't know why they call it b. I need to research. So here, what's my number in front of x? Minus 3. So that's my slope. What's my number out here by itself? Minus 2. So that's my slope and my y-intercept. And the way you graph these is you plot your y-intercept first. So my y-intercept is a negative 2. And then I plot my slope from there. Okay, I can't go down 3. Let me show you something. So that's the way we would normally look at the slope. But this is also true. That's the same number. 3 over a negative 1 is the same number. So I can go down 3 and over to the right 1, or I can go up 3 and back to the left 1. Is that confusing? Because you just look at your numbers. So 1, 2, 3, and then back 1. So I have a negative slope. That is a negative slope. And we do another line. And see this, if I went down 3 and over 1, it would still be on that same line. And there's my line. What about this one? What is my slope? 1/3. And I don't have a number out here, so my y-intercept is 0. This is called a proportion when your y-intercept is 0. That means it's going to go through the origin. So my y-intercept is 0. My slope is 1. This is rise over run, remember? So I go up 1 and then over 3. Because remember, I got to get up out of the bed before I walk to the bathroom. Okay. This one looks weird. It's just y equals negative 2. When it's y equals something, think about it like this. Y is always equal to a negative 2. It's a horizontal line. So no matter what x is equal to, y is always equal to a negative 2. If it's x equals, it's a vertical line. But that wouldn't be a function. And we're plotting functions, okay? So this one, my slope is 1, and my y-intercept is 2. If you don't have a number in front of the x, that's your slope. So my y-intercept, I plot that first, and my slope is 1, so I can go up 1 and over 1. I can also go down 1 and back 1. That's also equal to a positive 1. So you can manipulate using your knowledge of numbers, I'm going to sit down. You can manipulate these to fit onto your graph. But usually on the test, I make the graph big enough so you don't have to think about that. But in algebra, I will do that. Okay. Any questions so far? Is it coming back to you? Are you still lost? Or right now, do you think you can ace the portion that we just went over? If you don't think that, then you need to go back over this. I should have printed it out, but I didn't, y'all. Can y'all print this at home? You know what? I'll put it in with Cami, and then you can write on the screen. Okay, I'll do that. I'll go back and do that. But I don't usually use Cami unless I want it turned in, because most people are going to turn it in anyway. So I just want, you know what? I'll put it in Cami. Review for 1, 2, and 3. The review for the solving by substitution and solving by graphing, it won't be any more difficult than what was in Delta Math. Okay. But I'm going to go over those online too. So tomorrow, when you're at home, tomorrow, Thursday, and Friday, I'm going to put up all these, and I want you to just go over them to make sure, because y'all got to take your exam Monday. I don't know what the exam schedule is. I got to go find it. I'll let you know before we leave. All right. So let's take a pause right here, because I got to catch my breath, and then we'll come right back. Okay, now let's go back. Let's start back up with our word problems. This one gave you all a little heartburn, I remember, on the test. Jasmine and Joey. Here go Jasmine and Joey again. Jasmine and Joey were both trying to save up to buy the new Xbox. Joey started with $50 and added $25 a week. Okay, so when they say they started with something, that's your y-intercept. If they start at 0, your y-intercept is 0. You have a proportion. But if they say you started with $50, so and added $25 a week, Jasmine did not have any money to start with, so hers 0, 0. However, she decided she would save $150 a month. The Xbox will cost $650 total, assuming they're assume there are 4 weeks in a month. So in the beginning, it's Jasmine. Jasmine started with 0. Then after the first month, she added 150. She had 150. So the second month she had how much? 300. And then the third month she had 450, right? Okay, so we can plot this 0, 0. Let's say this is 150, 300, 450. We can make up our scale because it's our graph. 1, 2, 3. So, okay. So we can assume in the fourth month she'd have 600. 600. So her graph would be like that. In the fifth month she'd have 750. Okay, so Joey, he started out with $50, and then after the first week he had 25. The second week he had 50. I did it wrong. The second week he had how much? If we added 25, 75. Y'all said they let me do that wrong. Oh, they let me do it wrong on tape, y'all. Okay, and then he added 25, so that's 100, right? And then the third week is 125. Okay, so 50, 75, 100, 125. So at 0, he's at 50. So he's starting here. And that's his graph. So my function rule, y equals 150 times, we'll call it the number of months. So 150 per month. Y-intercept is 0 because she starts out with 0. Y-intercept is initial value. Here, we know he starts out with $50, right? And then he adds 25 each week. So that's Joey. So the independent variable for Jasmine is months. The independent variable for Joey is weeks. And then the second part, I'm not going to pull it up because I don't want to lose this. It asked, the next question was, who's going to have it first? So Jasmine, 150M, when will it equal to 650? So we divide both sides by 150. What is 65 divided by 650 divided by 150? Somebody. 6. Is it 6? 15 times 4 is 60. 5. 15. So she's gonna, in 4.3 months, but it says 4 weeks in each, 4 weeks in a month. So in weeks, that's gonna be about 17.2 weeks. We said 18 weeks. Okay, Joey, was it 650? We're gonna solve it. So subtract 50 from each side because y'all know how to do that now. That's 600. What is 600 divided by 25? Somebody do that for me. 600 divided by 25. 24. So it's going to take him 24 weeks. So Jasmine is actually going to get hers first. So we set it to the amount they're trying to save and then solve for their variable. I had to multiply hers by 4 because this is in terms of months. And Joey's in terms of, I could have divided Joey by, I could have left this like this and divided him by 4, and that would have been 6 months. So I didn't really have to do this. So she's 4.3 months. I could have divided by 4, and Joey would equal to 6 months. Because they said assume that there are 4 weeks in each month. Okay. So that's all to that part. That's the second sheet. And then I'm going to put up the 2 other sheets for tomorrow, Unit 2 and Unit 3. And I'm going to record videos going over them and post them. So I hope you all study. If you have questions, please, please, please send me a message. Wednesday, I'm free. Thursday and Friday, well, whoever's here is here. But Thursday and Friday, my prep is from like 11 to 12:30, 12:40. So I can meet you during that time also. All righty, y'all.